Hey everyone, and welcome back to Newegg TV. My name is Paul, and today we once again have a special guest in the Newegg TV studios. This is JJ from ASUS, and JJ, thanks for stopping by today.
Thanks for having me.
And it's great to see you. It's great to see all the hardware that you brought with you, specifically this one, and well, that one too. So I should stop rambling and talk about what we're going to do today, and that is that we are doing a demonstration of the NVIDIA GeForce GTX 680. We have an ASUS Z77 motherboard here, a platform that we're set up on, and we're going to be talking about GPU boost.
Yes.
Because it is a feature of the 600 series that has come out, and it's one of those features that maybe not everyone understands fully. And on top of that, we're also going to be talking about GPU overclocking, because that's another one of the things you can do with a video card, and particularly with your GTX 680 DirectCU 2 that we have right here, which has a beast of a cooler on it. It gives you a lot of overclocking headroom. So
yeah, definitely
one of the things that you guys have really designed the card for. That being said, what do we have going right here?
So, you know, the big thing, like you said, is that we want to help to bring a little bit more kind of clarity to the Kepler architecture. It's a really impressive architecture. I mean, outright, it's pretty much powering the fastest GPUs that are out on the market right now. It's really good at efficiency and at scaling, especially in multi-GPU configurations. And one of the new things that they introduced is, as you noted, was GPU boost, which is a dynamic way of adjusting the GPU clock frequency depending on TDP and depending on the actual temperature of the card. And so what we've gone ahead and set up here is essentially a quick test bed to illustrate this purpose. So we have a reference ASUS GTX 680 card that we've been running Unigen at in terms of, I think now probably about 10 minutes to allow it to go ahead and essentially cycle in, ramp up to a kind of normal default operating level. And we want to give a little bit of context to this, because the main reason being is that the default operating frequency of the GTX 680 is a little bit over 1 gigahertz. It's 1006. And then the quote-unquote boost clock is approximately 1058. So what this means essentially is that the card realizes that it's not achieving a maximum TDP value, okay, as well as it's operating under a certain temperature value, then essentially will ramp up the clock speed for the card up to 1058. And even in certain conditions, if those values are found to even be low enough, it will exceed the 1058 marker and even go higher, maybe 1070, maybe 1080, maybe 1090. Factors that, of course, could influence this would be the ambient temperature in your environment, the ambient temperature inside your case, and even the game load. Some games are going to induce a higher temperature point as well as a higher TDP consumption point than other programs, and this is also especially apparent like in synthetic stress tests, things like Furmark or OCCT, where you would push the card outright and you would peg it at maximum TDP and maximum heat output, so you would have an adjusted GPU boost value. So that's essentially what we've gone ahead and set up here, because we also want to give context as to why do we take time to design a non-reference card. Right? Why do we design different PCB components, different VRM, different cooling solutions? And part of that, especially with this type of architecture, is to help to provide better baseline performance, stock performance, as well as better overclocking performance.
And as you mentioned, since you have those parameters that the GPU sort of needs to stay within in order to make use of the GPU boost, having better cooling overall as well as better, cleaner power delivery, which you guys have integrated into your 600 series cards in general, is going to give you better performance.
Correct, exactly. So with that, let's go ahead and actually switch back over to the desktop and take a look and see what some of the performance metrics are for this card that's now been running for a little while.
Okay.
Okay, so let me go ahead and just quit out here. And here for you guys, just for reference, is that we're running in DirectX 11 mode, normal tessellation, shaders to high, antroscopic filtering to 16, anti-aliasing set at 2 times, and then we're running at the native resolution at 1080p, okay? So if we go ahead and now minimize that, we can see that we're set with the normal GPU boost clock value of 1058, right? Now, we're here using our actual application, Vga Utility GPU Tweak. This is especially designed to work with our cards, but it won't work with any graphics card actually on the market. If we move over to the left-hand side here in terms of our monitoring data, we can see actually a lot of information. And for one, we can see that the card was fairly audible. So we can see, one, that the fan will reach the maximum rotating value of approximately 60%, and that's a little bit over 2,500 RPM. So that's an important characteristic because it lets us know the acoustic parameters of the card, and this is also going to reflect the maximum temperature. So if we go ahead and scroll back up to the top here, we can see that the maximum operating temperature was approximately 81 C. Okay? Now, that's going to be important information because that's going to help to define what the maximum GPU boost clock frequency was. So if we scroll back down here, we can take a look and we can see that the GPU clock is actually boosted all the way to 1084. So it still had actually sufficient room to exceed the actual GPU boost value of 1058 and actually run pretty much consistently at about 1084. So we effectively had additional TDP and temperature room for the card to continue to essentially overclock and extend that further. And of course, you could continue to extend that by continuing to adjust the offset, so the increments of how much the boost clock would continue to raise, assuming there was sufficient temperature and assuming there was sufficient TDP.
So the 1058 value that anyone who's purchased a reference GTX 680 has seen, I don't know if I want to classify that as a conservative value, but it is the value that...
It's I'd say the overall average expected boost value.
Okay.
That NVIDIA is saying that in most situations, essentially, it's going to reach that marker. But they don't necessarily want to maybe promote that it's going to hit higher than that, right? Maybe 1084, 1090, maybe even 1.1 gigahertz, because they can't necessarily corroborate or know what are going to be all the other temperature values or the TDP values that you're going to have in place, right?
Now, if I have a video card and let's say I throw it in my system, I do some testing, I'm using GPU Tweak to monitor the boost clock values and everything, and let's say I'm similar to this card, I'm hitting up, somewhere 1080, 1090-ish. If the let's say the temperature in my system changes over time, let's say it gets dusty and maybe doesn't have as much airflow, will that value sort of dynamically change depending on
Yes.
Okay.
There are fail-safes that are built into the card that essentially will always override whatever it is that you even manually define within an application based on data that's being tracked by the sensors that are on the card. That includes the TDP and the temperature. So if all of a sudden the fan was maybe had more dust, debris, dander inside of it, wasn't actively spinning as much, maybe that 60% isn't effectively rotating to that 2550 RPM approximately, and maybe it's down to like 2000 RPM and temperature shoots up to 90 C, then of course we're going to now all of a sudden see that frequency go from that 1084 and maybe drop down to maybe 1040, maybe 1030, maybe even less. It depends. It could almost maybe get to the point of being close to the actual real base clock of a little bit 1006. Now another marker to take in consideration in this is going to be what's called the TDP, or the power target status, which we can see right here has almost effectively hit its maximum point. It's actually at 102. So that means we're effectively working at the maximum TDP, the power consumption marker. So at that point, you'd have a couple of different options. You could either go ahead and try to extend the power target envelope, right? Because we realize we're starting to buck the curve, okay? But not maybe make any modification to voltage and then go ahead and click on the actual GPU boost clock. But it's always best to kind of test this. So an example would be, let's say if I wanted to go ahead and try to extend the overclocking range, I could go ahead and maybe click this by 2 markers and go to 1078. And from here, you could go ahead and go back and run your benchmark. For expediency, let's say I could go ahead and just maybe run, let me see if I have Alien versus Predator on here. And we could just go ahead and run this benchmark. And this will go ahead and put sufficient load on the system to go ahead and ratchet up the GPU boost, and we can go check what the new frequency is. Now, if essentially we saw that the frequency didn't go over 1084, right, we know that it's essentially being pegged by either temperature or by TDP, right? Now, there still might be enough room. We've noticed in our internal analysis sometimes that even if the TDP is slightly exceeding 100%, you still might have slightly additional boost value available to you. Maybe not a lot, but enough that you should first try incrementally bumping up the frequency and then going in and seeing if you've now reached a new GPU boost frequency. If at that point you haven't, depending on your temperature or your TDP, you need to adjust accordingly. Now our TDP was already at 100% and our temperature was actually pretty high. It was already almost at 80 C. While that's not horrible, maybe it might be worth it at that point to, let's say, go ahead and adjust the fan from working at the maximum that was 60% to 70%, and then maybe setting the TDP to 110%. So we've given ourselves now more flexibility in the TDP and then more flexibility in the cooling performance. With both those in marker, the next step would actually not be to even raise the frequency at all. It would be to rerun back with your baseline of 1058 and see what the new GPU boost value is. Because if we hit 102 on 102 for our TDP at 1058, it meant that actually it might have even be able to boost higher had we actually had additional cooling and had we had additional TDP headroom.
So in this way, you can almost essentially get an overclock by increasing your fan speed?
Yes, and this is actually always the case. A lot of users always try to first usually just apply voltage, but cooling exponentially actually helps to provide better efficiency at actually power delivery. So the cooler you can always run a part, the better, because it provides more efficiency. But of course you have to be careful about it, because you don't want to get to the point where the card's running obscenely loud to get those cooling metrics. So you kind of try to find that balance. So sometimes it might be TDP, sometimes it might be temperature, sometimes it might be voltage.
Okay.
So we'll go back here and quickly look at the frequency, and we'll see if we were able to bump up. And we can see that we actually did. We bumped up to actually 1104, but we did not modify the TDP. So you can see we still actually had an approximate little bit of playroom there to still bounce up further than what was already being applied, even though we were essentially hitting that point. Now, if we go back to the TDP, let's see if it was going over. And we can still see that overall, the max is still effectively at 102. Since it didn't go to like maybe 110 or 113, it means that we're still more or less working within the same power curve, right? So that tells us that we didn't really need to adjust it. So at this point, really, probably the limiting factor is more temperature related. So you'd probably get more benefits from increasing the fan than you would from the TDP. But like I said, in our situation, because both of them are kind of high at this point, you might want to adjust both. But that being noted, I think the next step is to show some of the performance differentials between now the reference part that we kind of see how things are working and how it would work under, let's say, a non-reference part.
Okay, so that is our cue to pop in this GTX 680 Direct CU2, and this is the top.
That's correct. But this would apply to both the standard series as well as to the top series. The main differential between, of course, the two is with the top, we do go through a more extensive specific binning and sorting cycle to extend the margin in terms of the overclocking headroom.
All right, let's get this installed. And we are back. We have the Direct CU2 Top GTX 680 installed. We've been running the Unigine Heaven 3.0 benchmark for 10 minutes or so. And now we can see some results.
Yeah, and overall it's going to, I think, be pretty cool. I mean, keep in mind, of course, that the internal ambient is probably raised up a little bit because, of course, we were running the card beforehand. But overall, we're still going to have cooler results.
Are you saying it's getting hot in here, JJ?
Maybe a smidge. So same settings as we ran before.
Oh, we do need to point out that this, although this video card is overclocked from ASUS, we did, JJ dropped it down to the same clock speeds as the reference model before we ran this test.
That's correct. So we're running
overclock card running at stock speeds.
Correct. We're running at the same 1058, and that's to help to show, for one, the VRM design differentials in terms of how that could impact performance in the TDP, as well as our thermal assembly and our overall Direct CU2 design in terms of the heatsink and the fan assembly and how that's going to affect performance.
Okay.
So first off, we're going to go ahead and take a look at the max temperature, so we can see it's quite a bit cooler. We're only running at 65 C versus the temperature of the reference card, which was at 81 C. So we have a huge swing in that in itself. Okay.
That's a testament to the Direct CU2 cooler.
Yes, definitely, and I'm sure, as you guys heard too, it's significantly quieter. We're almost about inaudible in terms of the gaming footprint, while with the 680 card, well, I don't think it was exceedingly loud. It was, I'd say, clearly audible in terms of the actual sound. Now, going down from here, if we go ahead and take a look at some of the other metrics, we can go ahead and see that the fan duty cycle is another good characteristic to let us know that things were running really efficiently and cool, right? We were only looking at 34 in terms of the maximum fan duty cycle, and the fan RPM was essentially just a little bit over 1600, so 1620. So that's overall letting us know that's a very quiet level of operation in terms of the design. Now here, in terms of the actual boost clock frequency, we can see that we had a much higher value, 1123. Was our effective GPU boost in comparison to our previous GPU boost clock frequency. So that shows you that we're able to keep essentially and sustain a higher level of operation even if it was the stock card. So if a user is interested in looking at this card, even if they were looking at the base GTX 680, they're going to get better performance than a reference part, not only in terms of the acoustics, but in terms of the clock speed, so therefore frame rate, and then of course also the temperature performance. And of course the top part would even be higher than this because its baseline clock is even higher.
And that's sort of just showing an example of how even if you go back and set the GPU boost clock to the exact same as you would the reference card, it's really taking other factors into account, such as the the temperature and the TDP in order to actually give you that boost clock speed.
Correct. And we're also going to take a look here at the power target status, which we can see previously before on the NVIDIA solution was pegged at over 100%, so 102%. What we can see here in terms of our power target status was at only 86%. So this means that we actually have quite a bit of a reduced power target, but actually even at a higher frequency level, which shows to us the actual efficiency benefits of our card.
So is that a result of the cooler actually keeping the power delivery elements of the board
Not
cooler?
necessarily. It's more so also on the power componentry, so it's a combination of both in terms that, one, the card is working effectively more efficiently and cooler in itself because of the actual thermal solution, but also because the Digi plus VRM solution that we've now incorporated on this new 600 series set of cards with our SAP power components are essentially able to provide more efficient and superior power delivery to the card. So overall, we have better power delivery to the card. So that translates into a reduced power target envelope.
Okay, so definitely a great example of why you guys are so proud of some of the aftermarket work that you've done on the card as opposed to the reference model.
Well, definitely, I think just proof and concept at the end of the day. I think it's always good to highlight design points, but it's always nice to be able to actually illustrate how they can be beneficial. So I think the next part from here is we're just going to show some of the base overclocking functionality of how we could continue to extend some of this performance.
Okay.
So at this point, it'd be pretty safe that we could go ahead and just default, and default would take us to our actual top clock speeds, which would be 1201.
Okay.
Now at that point, though, we could also very easily go ahead and continue to extend the margin by, let's say, continuing to click up and, let's say, click 1241. And as I noted before, generally when you're overclocking a card like this with boost, my recommendation, though, is to not jump all the way that I've gone in terms. This is a more comfortable margin where generally I'd say that the majority of 680 parts that we're doing in our testing, especially with the top series cards, are going to have target profiles of somewhere between about 1230 to as much as about 1260 in terms of their actual GPU boost clock frequency. That being noted, I would generally not advise raising the voltage or the fan speed or the power target unless you see that you're recording either temperature or TDP values need to be adjusted. And voltage generally will come into play after you've gone ahead and maybe already adjusted TDP or adjusted the fan speed and not seen a direct increase. Now what I will tell you is in our testing, in the majority of situations, even up to about 1250, the TDP is generally not being saturated. So it means for most intents and purposes, you don't need to adjust the TDP on our card at all. Unless you're trying to really go for an aggressive high-level overclock, really in excess of a 1.3 gigahertz, then your core value is going to probably just be maybe fan speed lightly, or secondary to that is going to be GPU voltage. But in most of my testing, I essentially keep the card at all its default operating parameters and just do 10 megahertz bumps to that GPU clock, run my game, make sure that it's stable, make sure that things are running okay, and I'm good to go. Now, I will make a note in terms of some users who want to go ahead and adjust the memory clock frequency, is that you do want to be careful with overtly going too high on memory. What some users don't know is that when you go ahead and stress the memory, there is error correction that kicks in at certain higher frequencies. So your actual game could be entirely running. It could be quote-unquote stable at this higher frequency, but there's so much error rates that are being thrown out at that higher frequency that the error correction in the memory is coming into play, and it can actually reduce performance but not necessarily crash. So the memory essentially has kind of like a fail-safe function where it says, hey, I'm seeing all these flags, I'm going to reduce some of the performance benefit to make sure that things work correctly, even though you're clocked in at that higher speed. So you want to be very careful that as you increase memory frequency, just go very marginally and check your performance isn't dropping down. And if you're willing to take the time, try to do it asynchronously. So take the time to just keep your GPU at 100% stock and just slowly raise up the memory to see what the maximum frequency support on your memory is by itself. And then once you've kind of realized what that maximum value is, start to do a slow increase in relation to both the GPU frequency and to the memory frequency. But realize that overclocking both of them could have a lower overall value than overclocking them independently.
So changing one at a time, you'll be able to determine, for example, if you are hitting some memory errors, that sort of thing, and that's reducing the performance and the scores you're getting if you're running gaming benchmarks. That could potentially be the result of one or the other if you're doing both at the same time versus individually, so you know what exactly is causing the problem.
Yep.
Okay.
So I think from here we're just going to let it run, see what the new boost values are.
Okay. We will give Heaven a few minutes to run, and I don't know if you guys can hear, but this is the fan speed right now. Can you hear it?
And this is at a pretty overclocked value because we're already extended past even the top frequencies. So
right.
Still quieter than even our reference solution.
Yeah, so we'll give this a couple minutes to run, and then we'll come back and show you guys the results. And we are back once again. We have now been letting Unigine Heaven 3.0 run for a little while, say 10 minutes or so, and let's see the results.
Okay, so same exact settings. And we'll go ahead and take a look here once again at our temperatures, and we can see even at that heavily overclocked marker, we essentially only went lightly up to 67°C in terms of actually our GPU temperature. And from there, if we take a look at some of the other markers in terms of the fan duty, 36%, and then the fan speed only at 1710. So still really quiet, really cool. So that's a great marker from there. And then if we take a look at our effective GPU clock frequency, we're at 1307. So you can see that we've got a really healthy overclock, even extending past the boost clock that we've defined of 1241. So overall, showing you really the efficiency of the DirectCU2 with the SAP Power implementation and the Digi Plus VRM. And if we lastly take a look here at the power target status, where I was telling you that this isn't generally a limiting factor, we can still see that we've only hit power target status of 92%. Whereas remember, even on the reference at its baseline frequency, we're already at 102.
So some really good performance numbers right there. And just to reiterate, for those of you guys who might be looking into doing an overclock, if you're running a GTX 680, or also applicable to other cards in the GTX series.
Everything that we've discussed is 100% applicable to all the Kepler architecture. So this would be applicable to a GTX 690, GTX 680, GTX 670, and even forthcoming Kepler cards, because the GPU boost, everything that we've discussed is inherently part of that architectural design. And of course, if it's an ASUS specific card, then we're also going to get those benefits that we discussed as well.
Okay, so just to recap, go for GPU boost clock first. That's going to be your most effective means of overclocking, and most folks will be able to get all the performance they need just working with that. If you are interested beyond that, you can also try out going for increasing the power target, memory clock, or you can also work with the fan speed.
Yes, and fan speed kind of will also tie into the TDP. And then lastly, if you find that you're hitting actually like a crash, crash is generally would be an indicator that possibly voltage is your corresponding factor of an issue, right? So if let's say you were to see that you overclocked to 1241, but your temperature and your power target within normal levels, but it kept crashing out, then that's probably an indicator to let you know that probably the voltage might need to be modified. So then at that point, you would go ahead and increase the voltage.
Okay. Well, I hear them vacuuming outside, which means that we have been in here filming for far too long, so we're going to wrap it up. That's going to be all for this video. Thanks a lot, everyone, for watching. This, once again, has been JJ from ASUS. I'm Paul with Newegg TV. If you'd like to see more videos, you can check out our Newegg YouTube channel. If you'd like to see more videos with JJ, you can check out the ASUS ROG YouTube channel. Thanks a lot for watching, everyone. We'll see you next time.